A Harvard scientist is sounding the alarm. An interstellar visitor, 3I Atlas, is shedding metallic alloys that shouldn't exist. Real data from our best telescopes shows atomized nickel streaming from its core, but with practically zero iron, a chemical fingerprint that defies everything we know. Harvard's Avi Loeb is asking the question no one else wants to. If these metals aren't natural, what does that mean? The answer could upend our place in the universe, so let's explore this together. The discovery of 3I Atlas. What would you do if you saw something moving at 130,000 miles per hour that wasn't supposed to be there? On July 1, 2025, the Atlas survey team in Chile spotted a faint, fast-moving speck. The math instantly told a story that didn't fit any known playbook. Its path wasn't just a long loop, it was hyperbolic, with an extreme eccentricity that confirmed it was a visitor from deep space, moving too fast for the sun to ever capture it. This wasn't a comet on a return trip. Astronomers combed through archival data and found earlier images, firming up its trajectory. The object was born far beyond our solar system, possibly somewhere near the galactic center. By the time it was discovered, it was already inside Jupiter's orbit, making a one-time slingshot around our sun before it shoots back into the void. Its incredible velocity confirmed it. 3I Atlas is only the third confirmed interstellar object ever seen, a messenger from another star that will never return. This isn't just a rock, it's a clue from an unknown part of the galaxy. The nickel mystery. Imagine finding a fingerprint that doesn't match any person on Earth. That's what astronomers found in the light from 3I Atlas. Almost as soon as it crossed Jupiter's orbit, spectrographs detected strong signals of atomic nickel streaming from its coma. But the real shock wasn't what was there, it was what was missing. There was virtually no iron. This isn't just unusual, it's chemically bizarre. In every meteorite and comet we've ever studied, nickel and iron are cosmic partners, forged together in the hearts of dying stars and locked into the same minerals. When a comet heats up, they should be released together. Yet, data from the Very Large Telescope showed nickel vaporizing off the object, while iron was a no-show. Harvard astrophysicist Avi Loeb was the first to publicly highlight how unnatural this is. He argues that separating nickel from iron requires industrial processes here on Earth. In space, it's unheard of. It's like finding a gold ring without any trace of the other metals typically alloyed with it. This single chemical clue is so potent that it forces a profound question. Are we witnessing a freak of nature, or is this a deliberate engineered signature? Carbon dioxide dominance. Just when the nickel-iron problem had scientists scrambling, the James Webb Space Telescope delivered another bombshell. Pointing its powerful infrared instruments at 3I Atlas, a team of astronomers analyzed the gases in its coma and found that carbon dioxide was completely dominating the mix. The measured carbon dioxide to water ratio was a staggering 8-to-1, the highest ever recorded for any comet, whether from our solar system or beyond. To put that in perspective, typical solar system comets have CO2 levels around 4% of their water content. Here, CO2 is the main ingredient. This wasn't a fluke. The readings remained consistent across multiple observation sessions as the object neared the sun. While other gases like carbon monoxide were present, nothing came close to the CO2 spike. This kind of chemistry just doesn't align with our models of comet formation. Some researchers propose that its unique composition is the result of being cooked by cosmic rays over a billion-year journey. Others wonder if it's a clue to the specific conditions of its home star system. But the question remains, does this unprecedented chemistry point to nature at its most extreme, or is it another sign that something else is at play? The Oumuamua precedent. This isn't the first time an interstellar visitor has broken all the rules. Back in late 2017, astronomers detected one Oumuamua. At first it seemed like an asteroid, but its behavior was deeply strange. As it swung past the sun, it began to accelerate, pushed by a force that wasn't gravity. The problem? There was no visible outgassing, no tail, no coma, none of the typical rocket-like effects a comet uses to speed up. Oumuamua left nothing behind. Its light curve also suggested a bizarre shape, perhaps 10 times longer than it was wide, like a cigar or a flat pancake. The scientific community scrambled for an explanation: exotic ices, hydrogen outgassing, fractal dust. But no single natural theory fit all the data. It was into this debate that Harvard's Avi Loeb stepped. arguing that Oumuamua's shape and acceleration were consistent with an artificial object, specifically, an ultra-thin solar sail designed to ride the pressure of starlight. The idea caused a firestorm, but it cemented a critical precedent. When objects from other stars arrive, we shouldn't assume they'll play by our rules. Oumuamua prepared the scientific world to ask bolder questions. Ancient sky metal. Humanity's fascination with metals that fall from the sky is not new, it's ancient. Over 5,000 years ago in ancient Egypt, craftsmen hammered tiny beads from a mysterious iron that they didn't mine from the earth. Modern analysis of these beads from the Giza cemetery reveals a nickel content of nearly 30%, far higher than any terrestrial ore. This was the unmistakable signature of meteoritic iron. The story gets even more incredible with the dagger found in the tomb of King Tutankhamun. Discovered in 1925, the pristine iron blade was a mystery for decades. Finally, X-ray analysis confirmed its celestial origin. The blade contained 11% nickel and traces of cobalt, a composition that matched iron meteorites. The Egyptians even had a name for this divine material, iron of the sky. It was rarer and more valuable than gold, reserved for pharaohs. This history matters because it establishes a fundamental contrast. Terrestrial iron ores almost never exceed 4% nickel. Meteoritic iron, however, is rich in it. The same questions our ancestors faced, what is this strange metal and where did it come from, are echoing today as we analyze the impossible alloys of 3I Atlas. Kilonova formation theory. So if not aliens, what could possibly create pure nickel vapor in space? The answer might lie in one of the most violent events in the universe, a kilonova. This is what happens when two neutron stars, the ultra-dense corpses of massive stars, spiral into each other and collide. The resulting explosion is so powerful it forges heavy elements through a process of rapid neutron capture, known as the R process. In 2017, the gravitational wave event GW 170817 gave astronomers their first direct look at this process, confirming that neutron-star mergers create vast quantities of heavy elements like strontium, gold, and platinum. Nickel is also created in this cosmic furnace. Crucially, depending on the chaotic conditions of the explosion, some models predict that patches of the ejected debris can be exceptionally rich in nickel while being poor in iron. These aren't the slow-cooked metals from normal stars, they are forged in seconds and blasted into space. If 3I Atlas condensed from such a cloud of debris, it would carry a chemical fingerprint completely alien to our solar system. This provides a natural, albeit spectacular explanation for its strange composition. Asymmetric supernova theory. There is another natural forge in the cosmos violent enough to potentially explain 3I Atlas's strange chemistry, an asymmetric supernova. Not all stars die in neat spherical explosions. Some rip themselves apart in lopsided blasts that fling elements out in jets. The supernova remnant, W49b, is a perfect example. X-ray maps of W49b from the Chandra Observatory show that iron is packed tightly near the remnant's core, while other elements like sulfur and silicon are distributed more broadly. This kind of uneven explosion completely changes the rules of how metals are scattered into space. In these chaotic events, the inner layers of the star, where iron and nickel are made, don't mix evenly. Instead, high-speed plumes can punch through the star's outer layers, carrying specific elements with them. If nickel happens to be concentrated in the path of one of these jets, it can be ejected in bulk, leaving most of the iron trapped behind. If 3I Atlas formed from a fragment blasted out by such a supernova, it could have started its journey as a chunk of nearly pure nickel. This provides a second plausible, though very rare, natural path to its bizarre composition. Statistical improbability. Beyond its strange chemistry, the path of 3I Atlas through our solar system is so unusual it's hard to ignore. Avi Loeb and his collaborators ran the numbers, calculating the probability that a random interstellar object would have a trajectory that takes it unusually close to Venus, Mars, and Jupiter, all in a single pass. The result was a probability so small it's almost zero, about 0.005%. That's like flipping a coin 15 times and getting heads every single time. To Loeb, this strains the definition of coincidence and starts to look like a pattern. The object's path is nearly flat relative to the solar system's plane, but it's moving backward, or retrograde, against the flow of the planets. This combination allows it to skim past the inner worlds in a way that looks, suspiciously, like a survey flight. Critics argue that in a vast universe, rare events are bound to happen. But Loeb counters that if the odds are 1 in 20,000, and we've only seen 3 interstellar visitors so far, something doesn't add up. When you combine this improbable trajectory with the engineered-looking metals, Loeb argues it's time to take the artificial origin hypothesis seriously. The Golden Record Parallel. Could 3I Atlas be a message in a bottle? In 1977, NASA launched the Voyager 1 and 2 spacecraft, each carrying a golden record. This was a project led by Carl Sagan, intended as a time capsule for any extraterrestrial civilization that might find it thousands of years from now. The records contain sounds and images of Earth, music from various cultures and scientific diagrams, a snapshot of humanity etched onto a durable physical object. Sagan said, the launching of this bottle into the cosmic ocean says something very hopeful about life on this planet. Now consider 3I Atlas, an object loaded with alloys and compounds that don't fit natural recipes on a trajectory that seems too precise. The parallel is striking. What if its message isn't written in grooves on a record, but in the very ratios of its elements? A physical archive designed to survive a journey of millions of years. If its composition is intentional, then 3I Atlas isn't just a visitor. It's a courier carrying a record of another world's chemistry, and maybe even its technology. Atomic messages. What if we've been looking for the wrong kind of message? For decades, the search for extraterrestrial intelligence has focused on radio waves and light signals. But what if an advanced civilization chose to send a message encoded in matter itself? This is the provocative idea that the anomalies of 3I Atlas force us to consider. On Earth, scientists are already developing methods to store information using the ratios of isotopes in molecules, creating a kind of atomic fingerprint that can be read with a mass spectrometer. In biology, DNA stores vast amounts of information in a sequence of 4 chemical bases. Some theorists now wonder if the periodic table itself could be used as a sort of cosmic QR code. By arranging isotopes in a pattern that nature would never produce by chance, a message could be baked into a physical object. This message would be incredibly durable, immune to cosmic noise, and capable of surviving for billions of years. Spectrographs are now re-examining every bit of data from 3I Atlas, looking for these hidden patterns. The hunt is on for a fingerprint that says someone was here and they wanted to be found. The story of 3I Atlas leaves us at a profound crossroads. On one hand, we may be witnessing an undiscovered violent natural process, a kilonova or an asymmetric supernova capable of creating alloys we once thought impossible. On the other hand, the combination of inexplicable metals, extreme chemistry, and a statistically improbable trajectory has forced serious scientists like Avi Loeb to consider an engineered origin. This isn't just a theoretical debate. It's a real object with real data that is breaking our models of the universe. Either way, our understanding has to expand. Don't forget to like, subscribe, and hit the bell icon for more deep dives into cosmic mysteries. Thanks for watching Stellar Tech.